Hello YouTube, fellow math students and math teachers, DeVore here again, and today we're going to be doing the second task in Module 5 of the Mathematics Vision Project's Math 1 textbook. This is called Floating Down the River. We've got three friends, Alonzo, Maria, and Sierra, and they're floating on the inner tubes down a river. Alonzo notices that sometimes the water level was higher in some places than in others. Maria noticed that there were times they seemed to be moving faster than at other times. So they decide that they are going to collect data throughout their trip down the river. First off, we have this table that Alonzo created where we have time measured at 10-minute intervals. And with these times, we have corresponding depth of the river measured in feet. First question asks us to use the data Alonzo collected to interpret the key features of this relationship. When we say key features here, I'm really looking for four things. We've got domain, range, maximum, minimum. And then we're also going to add, for this video, we're going to add increasing, decreasing, which is something we're going to get a lot more practice in as we go. First off, the domain. Remember that domain is a fancy word for our inputs. When we have a table, our inputs are usually the first row of this table. We see that we have values spanning from 0 to 120. And that's all that's really on this graph. And the thing is that we can, I think, all agree that there should be measurements, say, at 5 minutes, 20-something minutes. There should be measurements in between here. They're just not shown. So we would write this interval as 0 to 120, including 0 and 120, because those data points are on our graph. Our range, remember, is a fancy term for our outputs. Our outputs are down here on the bottom. We look for our smallest range value, which I see here is 4. I look for my biggest, I see 12. And again, I think that we can all agree that at some point we will have 4.5 feet, we'll have 10.25 feet. I think we can all agree that at some point the river will be at all of those depths, and so it would be appropriate to include all of those. All right, we're looking for the maximum depth of the river. And generally, let's see, I see, here we go, at 90 and 12. We generally just use the input value. We say at t equals 90. And you could put 90, 12 as some kind of an ordered pair, but I would prefer if you just give me the input value that goes with the maximum. It just makes it easier for me to read. For the minimum value, let's see, we said it was 4. I see 2 spots where that happens, which is okay. Just so long as we don't have 2 different depths at the same time, then we're okay. We would write that as t equals 0 and 60. Which means that at 0 minutes and at 60 minutes, we should have a minimum value on our graph. Now, the increasing part, we're looking at where the depth is increasing and where it is decreasing. All right, so here I have from 0 to 10, so 0 to 10. And then to say that there's more to it, that there's another time span, I'm going to put this U here, which stands for union. It's just a way of saying I've got a bunch of these intervals and they all are where it's increasing and just split up a bit. Okay. Oh, nope, this goes to 30 because we've got 4, 6, 8, 10. My bad on that. This should be 30. Then where else does it start? Starts decreasing, decreasing, and then it increases again from 70 to 90, and then it goes back down again. All right. Now we're just going to look at where the holes are. From 30 to 70, it's decreasing. And from 90 to 120, it's decreasing. Just filling in where everything is, because in this case, if it's not increasing, then it must obviously be decreasing. Think about it that way. Cool, there's our table. Now we're going to do a similar kind of thing with our graph. We have a distance graph here, just plotting how much distance they went throughout their trip. Okay, and again, we've got domain, range, maximum, minimum, increasing, decreasing. All right. When we're on a graph, the domain is represented as this left-right. It's our x-axis. I see my smallest value right here where the graph starts at 0. And then if I count, see the graph ends here. That's the farthest right that it goes, and that corresponds with 120. Just like above, that makes sense that we'd be measuring the same right here. The range is my up-down. So I look at where it's lowest, which I see is here at 0. And then I look at the highest point in the graph, which is right here. And let's see, we're counting up by 2,000s, which makes this at 16,000. All right. My maximum value, we look for the tallest point in the graph, which is at t equals 120. It's right here at the very end, which makes sense because we're going down a river and we are hopefully not paddling back and trying to go through the rapids again or whatever. We're just going in one direction here. Our minimum is down here. It's where it's lowest. And again, that makes sense that before we even go anywhere, that should be the lowest distance that we have. Okay. We can look at the graph and we can see where it's increasing. It's where we're going to the right, and the graph is going up. Well, it's going up the entire time. We're going to put our interval as 0 to 120. And it's not decreasing anywhere at all. So, never. It does never decrease. Right, there's our graph. Now we're going to answer, let's see, Sierra looked at the data collected by her 2 friends and made several of her own observations. Explain why you either agree or disagree with each observation made. First one, the depth of the water increases and decreases throughout the 120 minutes of floating down the river. Well, yes, we saw that, and in fact we said when it happens. It just happens throughout the whole thing. The distance traveled is always increasing. Yes, because the graph is always increasing. That's why. That's really all it is. We're not backtracking and doing rapids again. The distance traveled is a function of time. Now, this is something that is not always talked about. We've got these 2 things here. We've got distance traveled, and we've got time. When it's written this way, when it's saying that something is a function of something else, what that really means is the second thing that's written, the is a function of part, this blue part, that is actually my input, and the green is my output. In our distance traveled graph, is time our input and the distance traveled our output? Well, yes, it is. The answer is yes, because time is our input. It's our domain. Let's be a little fancier here. And the distance traveled is our range. That's why. The distance traveled is greatest during the last 10 minutes of the trip than during any other 10-minute interval of time. This involves us looking back up here at our graph. So we're looking here at the last 10 minutes here. Just kind of draw a little box right here of where we're looking. Now, when we're looking at a greater rate of change, that's a fancy way of saying it's steeper than anywhere else on the graph. So if we look, we've got this little part right here, we've got this little part right here. You know, just looking at these little 10-minute chunks here, I think that we can agree that right here, right before that last chunk, it's a lot steeper than the one that they're saying is the steepest. And that's really what I want you to be able to eyeball here. So let's go down here. Say, no, the graph is steeper at another interval. And it's right around 100 to 110 minutes. The domain of the distance time graph is all real numbers. When I say all real numbers, I mean all numbers. Any number that you can possibly think of as many decimal places as you would like. But all real numbers also includes negative numbers, which is awkward because then we would have negative time, and that's awkward. Let's not be awkward. So, no, our graph cannot be negative. Also, we are limited to the interval 0 to 120. We don't have a time measurement for time is 150. It's not in our data. We're just going to assume it doesn't exist. So these are our two limitations. It can't be negative, can't be outside of this interval. The y-intercept of the depth of the water over time function is 0, 0. Remember that when I say y-intercept is a fancy way of saying x is 0. When x is 0 on this graph right here, my output is 4. So nope, does not work out. No, it is 0, 4. Distance traveled increases and decreases over time. Well, no, we said that it's increasing at every point on this graph. They never backtrack and go do the rapids again. No, the graph never decreases. The water level is a function of time. Let's use our colors again, because I think that works out really well. Here is our input, and here is our output. The water level is a function of time. Yes. Yes, it is. Yes. It just is. We can say here, because time is our domain, and the water level is our range. Cool. That's done. That was easy. The range of the distance time graph is from 0 to 15,000. No, it is not. If you remember from above, our range is from 0. So the range is from 0 to 16,000. They were off by a little bit. The domain of the depth of the water over time is from 4 to 5. No, we can look back up at what we wrote. Our domain is from 0 to 120. In fact, the interval that they gave is a little more prudent maybe for the range, but it's not even the whole range. They're missing a ton of numbers. The distance time graph has no maximum value. Well, if we look back at our graph, there's a maximum value. It's where it ends. It's there at the very top. So, no. The maximum is at t equals 120. Finally, the depth of water reached a maximum at 30 minutes. Well, let's look back here. Looking at our depth graph, our maximum is 90 minutes, not 30 minutes. So, no. The maximum is at t equals 90. And that's it. That is floating down the river. So thank you so much for joining me for this video. If you like what you see, please remember to like and subscribe and send me a message. That way I know that you like what you see, and if you would like me to do other videos that aren't currently on my channel. So remember, be awesome, and I hope you have a fantastic day. Bye-bye.